Hey YouTube. So welcome to video number 10 of our little NixOS configuration series. In video number 8, we were talking about Docker containers and how to declaratively use Docker containers in our NixOS configuration. And I got a couple of questions concerning NixOS containers. I had planned NixOS containers for a later video, but as some of you seem to be interested in this topic, and especially in comparison to technologies like Docker, I can as well do it now. So here today is my NixOS container video. Let's get into it. When we have a look into the NixOS documentation, we can see that the topic of NixOS containers is quite straightforward and quite simple. So when we have a look here, we have a NixOS container command. So when we enter NixOS container help into our terminal here, we can see there are a couple of commands. So we can list containers, we can create containers, destroy, restart, start, and so on and so forth. And this looks at the first glance very similar to technologies like Docker and Podman. When we have a look at the documentation here, you can see all we really need to do here is we need to just tell the NixOS container command to create a container, and then we can give it a config flag, and then we basically pass in a Nix expression. So in this example, this is just basically enabling the OpenSSH service and to add an SSH key for the root user here. So let's just try this out on our virtual machine. And right now, how we have built our system, this will not work out of the box. When we try to create a container named foo here, we get an error that Nix packages / NixOS was not found in our Nix path. And that is something we need to fix first on our Flake here. So the problem with this right now in our Flake configuration is that the container command does not really know where to get the packages for the container from. There are kind of two options to solve this problem now. We could add channels to our configuration and to our system here. This is something you would typically have on a non-Flake system configuration. However, this approach would be static because when we use traditional channels on NixOS, these need to be somewhat maintained and kept up to date. So to avoid manual updates, a better solution, in my opinion, is to add the Flake inputs to our Nix path. And this is something we can do in our Flake configuration. So when we are back at our Flake configuration, the first thing I need to do is, of course, I need to create a new branch for video number 10 so you can follow along with the code. And in our hosts common configuration, we have this block here, which configures our Nix configuration for our system. As you might remember from earlier videos, we enable the Flakes commands here. We add the trusted users who are allowed to rebuild the system. And here we have some garbage collection and some other things here. And down here, we have the Nix path. And here we can just add our Flake inputs to the Nix path. So we need to make a couple of changes here. So the first thing I would like to do here is I will create a new variable here, which I name Flake inputs. What we will do here is we take one of the library functions for filtering the attributes, and this function will basically go through the attribute sets and only return the ones of type Flake here. Down here at Nix path, I will just enter another function here. And what this does is it will go through the results from the Flake inputs and basically just create a list in this format here. So here we have the Flake name and then equals and then Flake colon and the Flake name again. So this will basically look something like this in the result. So we will get a list, and this will be the format Nix packages equals and then Flake colon Nix packages. When we have this in our Nix path, NixOS will be able to use the package definitions from our input flakes. So I will just put this away. And as you can see, we had the same function used here as we have now in our Flake inputs. So we can just refactor this code here for brevity. And what this does is it will add our Flake inputs into our Flake registry. So usually you would go like nix run and then GitHub colon and then NixOS Nix packages and the program you want to run. And of course, this works perfectly fine. But when we have added our input for Nix packages to the Flake registry, we can just directly run Nix packages say here. And this saves a little bit of time and effort when you enter a command like this into the command line. So now we can just rebuild our system and then try the container command again. So when we get back to our virtual machine, and now we try to create our container again. We can just do a NixOS container list, and you can see the container has been created. And what we can do now is we can just start our container, and when we have a look here, you can see that the container has been started, and we can log into our container like you would usually do with a Docker container or something similar. When we have a look here, you can see that our container has its own file system. And when we cd into etc NixOS, you can see there's also configuration.nix created. So what this means is when we create a container on NixOS, this will basically create something similar to a lightweight virtual machine, which has its own system configuration. And that can be configured as you would usually do it with the normal NixOS system. And we can also reach the file system of the container just from our host machine because NixOS will create the file system in the var lib NixOS containers and then the container name directory. And when we look here, we have the file structure for our container, and I can just go into etc NixOS here. And here I have the configuration.nix, for example, just edit the configuration here. And I don't know, I could just enable a simple web server here. And then I can just stop my container. And update my container. And of course, I need to start it again. And now I can log back into my container. And when I check for the web server service here, you can see that the web server is up and running. So as you can see, this will basically allow us to create something like a very lightweight virtual machine inside of NixOS, which can have its own NixOS configuration and which can pretty much run in isolation. It's not fully isolated because these containers share the Nix store with the host machine. This is also not a real virtual machine, but it is very useful when you, for example, want to run multiple instances with different configurations on the same system. And of course, we can also make the container configuration as part of our system configuration. And that is what we will do now. Just for now, I will just stop the container. and also destroy our container. And then I will head back to our system configuration and get started defining a container within our Flake. So I will just go to my host folder, and here we had services and containers. And just for now, I will just create a file http://nix for our web server. And on the default.nix, I will just import our http://nix file. And we will start with a very simple configuration. We just define containers and then the container name, and we put this to auto start. So each time the system is built or started, the container will be started and executed. And here we have a config option, and this config option basically just takes a regular NixOS configuration. So when we save this and we add the new files to our Flake repo, we can just rebuild our system. And when I head back to my virtual machine and list my containers, you can see that the container is present here. And when we enter machine control, you can see that the container is also listed here. And when I call my web server here, you can see I get the default HTML response that comes from the Apache web server, which is just saying what. And in order to have access to our little web server from the outside and not only from the host, we need to make some changes to our host configuration. We need to enable port 80 on our firewall. When I enter the IP address of my virtual machine, we can see our web server is up and running. And of course, on my virtual machine, I can just log into my container. And right now, the container has its own permanent file system. So for example, when I cd into my root directory and just create a file, then I can just log out. And when I stop the container and start the container and we log in again, we can see our file is still present. I can just set the ephemeral option to true and just rebuild our system configuration. And when I now log back into my container and cd in the root directory, you can see there's no file. So this will basically behave like a Docker container. You can make changes to the file system, but as soon as you rebuild the container, all these changes will be gone. And that's how I like Nix containers also to behave. And instead of creating permanent files here, we can just mount file systems from our host machine into our container. So we can just map file path on our host machine to the file path inside of our container. And we can also set if the container is only allowed to read or if the container can make changes to our folder. So when I save this and rebuild my system configuration, this of course needs to be outside of our container system configuration. So we try this again. And this gives an error now because we are not able to mount the folder on the host machine because it doesn't exist. So I'll just create the folder. And now we try once more. And now this is working out. And when I cd into this folder and let's say I create a new file, and then we log back into our virtual machine and get to our root folder, you can see there's a data folder in here. And within this data folder, we have our file. And as we set read only to false, I can, of course, inside the container create a new file. And this new file will, of course, be available on my host system also. So that's an easy way to work with the NixOS container like you would do with the Docker container using volumes. And right now in this configuration, the container is sharing the network with the host. We can also set up a private network here, and this will enable us to have a private network between the host machine and the container. This will also allow us to have different containers talk to each other like on a Docker network. So we just put in private network equals to true. And now we can just define a host address and a local address for our container and rebuild our system configuration. And when we look at our network configuration, you can see that NixOS has created a virtual network. And here is our host IP address. When we try to reach our web server here, we don't get a result. And the problem here is really our container has now its own network configuration. So what we need to do is we need to add the option for networking firewall allow TCP ports and then the port 80 here. And this is exactly how you would do it on any NixOS system. So when we save this and rebuild our system and try this once more, you can see we can reach our container from the host on port 80. And of course, we could just quickly duplicate this service here and, for example, have another instance running on another IP address. We build our system. And now you can see we have two containers running with an HTTP server. And here we have the IP addresses from the host. We can reach both machines. When we log into our container now, we can access our host machine here, which works perfectly fine. But we try to reach the other container, we don't get any results from the ping command. And the same goes for any external service. So we are not able to reach Google from inside the container. And to fix that, we need to go back to our host configuration. And on our host machine, we need to enable network address translation. So we do that with networking.nat.enable equals true. And then we need to set the interfaces. And when we have a look at our virtual machine, you can see we have two virtual Ethernet interfaces here, one for each container. And there are different possibilities. So you could do a fine-grained configuration here and list any individual container, but we can also do this with the regular expression here. So we just assign all interfaces that start with VE dash, and then we just define the external interface, which is this one up here. And now when we save this and rebuild our configuration and just clear this out, and when I log back into my container and try to reach Google, you can see I get a HTTP response here. And I also get a response from my other container. So with this configuration, we can spin up multiple containers for the exact same service on the same machine. One missing part to have this really useful is basically pod mapping, because usually you will have different containers for different purposes. And especially when it comes to web services, you will have them listening on different ports and have something like a reverse proxy in front. For this, we can, of course, configure port forwarding here on our containers. We can set the option forward ports, and here we just have a mapping. So we have a container port for port 80, and we have a host port for port 80 also. And on a second one, just for example purposes, we put the host port to 8080 and rebuild our system configuration. Now when the system is rebuilt, you can see we reach our first container on port 80 and our second container on port 8080. And what you might have noticed is we are getting a warning here for the system state version per container, because we did not set the system state version on our container configuration. So what we can do here is we can set the system state version. And now when we rebuild our configuration, you can see this warning is disappearing. And what we can also do is, of course, instead of fully writing out our configuration here, we can just say import, and then we say, so just like this. And then we create a new file and just paste our configuration and remove the semicolon here. And now we can just add it to our repo and rebuild our system configuration. And this will also work, of course. So this depends a little bit on how complicated your configuration for the container is and how readable you want this to be here. So this was a basic rundown on how NixOS containers work in NixOS. Actually, this is not exclusive to NixOS. You can basically do the same on any Linux distribution, but NixOS, of course, makes it very easy to build this just with our NixOS configuration. That's it from me today. If you have any questions, just drop a comment and I will try to help out. And yeah, have a nice day. Bye bye.